On the calculator, graph the function y equals 7x in y1, and on the same axes, graph ddx of 7x as y2. So we're doing a function, y equals 7x, together with its differential on the same graph. So we'll put 7x in here, and then we need to go and do ddx of 7x just here, and we'll plot both of them. And we're going to need to change the axes a bit to see both of them. So if we go from -10 to say 10, that should do the trick. And so the blue one, of course, is our 7x, and the red one is the differential, which we can see by looking at it is just the line y equals 7. So we want to sketch both functions here. So here we have y equals 7x, and then here we'll have y equals ddx of 7x. Now differentiate y equals 7x. So if y is equal to 7x, that means that dy dx is just equal to 7. Comment on the connection between the graph of the function and the derivative function. So here's the function, and it's a straight line with a gradient of 7. So the gradient function, which is the red one, is just 7. So the gradient of this one is 7. When we plot the gradient function, we're just plotting y equals 7. On which side of the x-axis is the gradient function? Well, it's above the x-axis. Why is that the case? Well, that's the case because the gradient here is positive. If the gradient is positive, then the gradient function must be positive, i.e. above the x-axis. So if the function had been y equals -7x, then dy dx would have been -7, and if we'd plotted that gradient function, it would be the line y equals -7 down here. Here we would have a negative gradient, and therefore it would be below the x-axis when we plot the gradient function.